Okay guys, so today we're going to solve the problem reverse a linked list on Leetcode. So the question says, given the head of a singly linked list, reverse the list and return the reverse list. Okay, so what the question says is that if you're given a question, you're given a linked list like this 1, 2, 3, 4, 5, so you have to reverse the linked list and just paste the output. So if it's 1, 2, 3, 4, 5, then the output will be 5, 4, 3, 2, 1. Okay, so yeah, so the question is very straightforward and it's a pretty common question. And okay, so to solve this, there are like two approaches we can use. So one is the iterative approach and one is the recursive approach. So we'll be discussing both the approaches today. So firstly, let's start with the recursive approach and then we'll go to the iterative approach afterwards. Okay, so to explain the recursive approach, okay, so this is the question with what we are given over here. Okay, so now what we are going to do is, I'll just code this side by side as I do it. Let's put it over here. So firstly, what we're going to do is we'll create a reverse, reverse, then node, comma, prev. Okay, and we'll check if node is equal to none, then we'll return prev. Else what we'll do is next, comma, next, let's do this, next element, then comma node dot next is equal to, so next element will point to the node and this will be prev. Okay, and then we'll just return reverse of, then we'll just return reverse of, so this will be, the node will be the next element now, and this would be the node, right? And then we'll just return reverse REVRSE. So yeah, let's just copy this, and so it's the same thing. So yeah, head, reverse of head, and let's make this prev is equal to none. So this is the very first time when we do it, it will be none. So let's run the code. Okay, so we have an error which says maximum recursion depth reached. Okay, so let's check it out. So first of all, I found an error here also, and what's the error? So let's see this thing. Yeah, so it has to be node dot next. It should point back to node dot next. Next element is the next. Yeah, so yeah, and submitting it. Yeah, it's submitted, guys. So let me explain you the approach now. Okay, so let's see. Yeah, okay, so what's happening over here is, let me just make this big. Okay, so what's happening over here is, let's just do a dry run of the code, and I hope you guys understand through the process because it's pretty straightforward. So what we're doing is we're making a new function called reverse, and we're giving it two variables, so it's like node and prev, and we're assigning prev equal to none. So the very first time when we run the recursion, run the function, prev's value will be none. So we have here p is equal to none, and node is basically just head. We're returning reverse of head, so node is just head over here. So this is the node portion, so this is the node and its value is 1. Okay, so now let's just run the recursion and see what's happening. So the very first time when we run it, what will happen is it'll check if node is equal to none. So node is not none, but if node would have been none, we would have just returned prev, which is none actually, and we would have got the answer as none. But now since node is not equal to none, what we'll do is we'll create a next element variable. So this is the next element variable, okay, and a node dot next value, right? And node.next, which is basically the pointer of this, this variable's pointer, which is pointing to 2, right? So this node's pointer, which is pointing to 2, right? And we'll make this node's pointer point to none over here, which is make it point to prev, which is none, and we'll make this as the new node, and we'll create a new next element called 2. So when we do a new recursion step, so when we go into the recursion over here, okay, so let me rub this, right? So what's happening is we're creating a new element called next element, and we're making it making it equal to the current node's next value, which is 2, right? So this is 2, and we're making the node.next, so the current node, which is 1, its next value equal to the prev value. So currently the prev value is none, so 1 will now point to none over here. Okay, now when we go to the recursion step over here, this one, what we'll do is we'll pass the next element as the new node. So now this new node is equal to the next element, which is 2, right? And this prev is now equal to 1, which is the node value basically. So the node value is 1, so the node value will now be, prev value will now be 1. Okay, now we'll check if our current node is not equal to none, which is, if it's equal to none, if it's equal to 1, then we'll just return prev. Okay, now if we return prev over here, we'll just get a node with 1 as the value, but it's not none. We have a value 2. So what we'll do is we'll do a next element equal to the current node's next value, which is 3, right? We'll make it point to the current node's next value. Okay, and we'll make the prevs. So what we'll do is we'll make this current node's next value point to prev, which is 1. As you can see over here, the current prev is 1, so we'll make the current node's next value point to prev. Okay, so on, we'll just keep on doing it. What will happen is we'll make this, now when we pass this, now when we go to this recursion step again, the next element is passed as the node, so this will now become the new node for us, which is 3, and the prev would be 2, and the node will become the prev. So 2 is now the prev value. Now what we can see is in the step over here that it's not, the node is equal to none, then return prev. So it's not none, so we'll not return prev. We'll make the current next element equal to the node.next, which is 4, right? So 3 is the current node and next is 4, so we'll make it point to that, and we'll make the pointer of this node point to its prev. So this will be removed and we'll make it just point to prev. So this would just point over here backwards. Okay, so basically this is what's happening, guys, and the same thing would happen for 4 and 5 as well. We'll be passing 4 as a new element and new element and node as the previous element. So this would be 4 would be the new node, new element, new node, and prev would be 3, right? When we get this, we'll make the new element equal to 5, the current node's next value, and we'll make the current node's next value point to prev, which is 3 in this case. So it will point like this. This would be removed, and now the same thing happens for 5 as well. We'll just do everything the same and make this point to 4, right? So yeah, this is basically what the recursion method is, guys. And yeah, let's just comment this out and let's go towards the iterative approach now. Now for the iterative approach, what we're going to do is, let me just clear this, guys. So 1 second. Okay, so it's cleared. So now what the iterative approach is. So now what we're going to do in the iterative approach is we're going to run a for loop. We're going to run a while loop actually. So let me just code it out and I'll explain the code to you guys. So what we'll do is we'll do a first equal to head, first equal to cur equal to head. Now second equal to head dot next and cur dot next equal to none. So while second, third is equal to second dot next is equal to first, is equal to second, and second is equal to third, and in the end we just return first. Right, so let's run the code. And yes, so let's submit it. So we have an error over here, so let's check the error. Get an error over here. Okay, so we just need to put an if statement over here. If head is equal to none or head dot next equal to none, and just return head. Okay, so let's run and let's submit the code. Yeah, it's submitted, guys. So let's see what the approach is. Okay, so what we're doing in the iterative approach is we're basically assigning the first value. We're creating a few variables over here. So the first is equal to the very first value. Let's make it 1. Then we're making second equal to 2. Right. Now what we're doing over here, we're going to check while the second value is present or not. So while second is true, we'll go inside the loop, and before that we're actually just making this value equal to none, because this will become the last element, and the pointer to the last element in a linked list is always none. So we'll just make this equal to none and not pointing to 2. Right. So now what we're checking is with the while second value is present or not. The second value is present, which is equal to 2. So now we'll go inside this loop. Right, when we go inside the loop, we'll create a new variable called third. So we'll create a new variable called third equal to 3. Right, now what 3 is equal to? Now 3 is equal to second dot next. So second dot next is 3. So 3 is the third element. Right, now what we're doing is we're making the seconds pointer point to 1, to the first element. Right, so second dot next is equal to first, so making it point back to first now, like this. Okay, and now first is equal to second and second is equal to third. So first will now be equal to 2 and 2 will now be equal to 3. Second will now be equal to 3, and now we'll continue running the loop for 3 by checking if 3 is present or not. Right, now when we ran the code, we see that 3, so the third value over here, so this third will now be equal to second dot next. So second dot next is 4, so this third will be equal to 4. Right, now third is equal to 4. Now second dot next is equal to first. And when second dot next is equal to first, okay, so second is, we have is 3. Now we'll make its pointer point to the first, which is 2. Okay, and we'll make this equal to, first is equal to second and second equal to third. Right, so this is basically just a pattern, guys, what we're gonna follow for solving this problem. And now similarly for second is equal to true. Now 4 is true. Now what we're gonna do for 4 is we're gonna make since 4 is true, yeah, so what we're going to do is make 4 equal to 3 equal to So what we're going to do over here is we're going to make third is equal to second dot next, right? So what is second dot next, which is 5? So third is equal to 5, and we're going to check for that. Okay, we're going to check for that. When it's equal to 5, now second dot next is equal to first. So 4 is now point back to 3 over here. 4 will now point to 3 over here, right? And once that is done, this will be equal to 4 and this will be equal to 5. Alright, now what we're going to do is we're going to check for 5. Now second is again true because 5 is present. Now we're going to make third equal to second dot next. Now second dot next is none, so third will be none. Okay, now second dot next points to first, so now 5 will point to 4. Right, now first is equal to second, first will be equal to 5, and second will be equal to third, which is none. Now when we run the loop, we see that second is not true because it's none, and we'll just stop and we'll just return the output as, you know, this. Now currently the first is 5 at 5, so we're going to return first, and when we return first, what we'll get as 5, 4, 3, 2, 1 and none as the output. And yeah, that's it guys. So this is basically the iterative approach to solve the problem. Okay guys, so that's all for today's video, and if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.